Okay, I need to have this. Okay, so today we will move to chapter 3 about pandas. So another package. Okay, and last chapter we discussed NumPy package, and for NumPy package, the major data structure is ND array. And if you recall, the ND array is homogeneous. The data type, okay, to can only support unique data type, even though later on we learned structured array. But structured array is because you define multiple data type into one as a new customized kind of data type, okay? And also regarding ND array, if you recall, the major advantage is it will support intense scientific computing, okay? And because of its vectorization, feature and its speed is faster. And we also discuss one example to show the difference between the calculation using ND array versus the general Python's list. Okay, so NumPy is a pretty important package. And today we are going to learn another very, very important package. It's called Pandas, okay? And Pandas, this package especially used for data analytics, for data analysis, okay? And we will see its features and how to use it. How do we move to the next page? Oh. Yeah, okay, so let's first take a look at Pandas package. Okay, so Pandas package, it is specifically designed for data analysis. Okay, so for data manipulation, later on we will see in our examples. Okay, so this is different from NumPy. NumPy is for scientific computing because it can support very large array. Okay, and for a lot of scientific computing, it involves larger matrix. So that's NumPy's advantage. Okay, so over here, its advantage is for data manipulation. Okay, so that's one of the major features for Pandas. And for Pandas, its data structure, there are two types. One is series. Series is for one-dimensional. And the second is data frame. This is two-dimensional. And data frame, later on, we will also see, it's mostly like the Excel spreadsheet. Okay. Yeah, like what over here it also mentions. And also Panda supports various operations so that it also supports like customized operation. Okay, today we will also see a little bit so that data make data manipulation and analysis easy and also fast here. Okay, especially for large and complex data sets. But this is all programmed, okay? And later on, we will also explain because its purpose is for large and complex data sets manipulation, and especially for huge data set, a lot of time a spreadsheet even wouldn't work. Okay, so for Pandas, that has a huge advantage in this regarding. Okay, then the question is says why pandas? Is it so previously we also discussed NumPy Excels for scientific computing, okay, especially for large numeric data sets. And for data analysis, if you play around with Excel, you got the experience. Is it Excel? It's not like the ND array, the data type is the same. So for the Excel sheet, normally it deals with heterogeneous type of the data type is heterogeneous. So the data set is also normally is large. Okay, and in this case, if you use conventional the Excel spreadsheet, sometimes it for especially for huge data set, it may not be able to solve using spreadsheet. Then at this time, Pandas it offers distinctive advantages. Okay. So over here it explains normally for Excel spreadsheet, you can load the data, yeah, no problem. And then you can then using Excel to do some analysis and also using Excel sheet to do the graph generation, okay, and also do some data modeling, okay. So Pandas can do all of that, what Excel sheet can do. In addition, it also can do some advanced data manipulation, okay, and complex modeling, okay. So if you also use machine learning algorithms, so you can do complex modeling. So that's also one of the advantages. And also its efficiency and the skill. So skill, like previously explained, is that spreadsheet normally has a limitation. For huge data set, if you want to load that data into some single sheet, that's not possible, okay? But then for Pandas, it doesn't have that limitation. Hold on, okay, it says my internet connection is not stable. Okay, and so Pandas has an advantage to process large and complex data set. Yeah, for Excel sheet, because it's visualized in the sheet, is it, and on screen it has very limitation. But for Pandas, DataFrame, then it's a different story. It's all program. So it can handle also very complex data set. And regarding data processing, Pandas, it says, offers a wide range of operations, also including handling missing data. We will see today filtering. We will also see sorting, grouping, and merging. Okay, and those are normally very hard to do in spreadsheet. And also Pandas offer advanced functions for time series analysis, okay, aggregation, and other tasks. Sometimes like a spreadsheet even cannot manage it effectively. Okay, so that's the advantage of Pandas package. Okay, for install and testing, so if you use Anaconda, then it came with Anaconda. Okay, if you install individually, and here the textbook also give you the step to do installation of Pandas. After you install, then you verify how to verify. You can also testing your Pandas installation. Okay, here I also give a very simple script you can use. And over here to give the comparison between NumPy ND array and for Pandas data frame and the series, okay. And previously we explained Pandas has two data structure, series and data frame. For series, one-dimensional. Okay, but later on, we will see in our example. So this array is different. We call it labeled array. Okay, so its index is labeled. Okay, so here, like I said, label serve as index. So you can use some named label as index. And for data frame, so data frame is kind of like the spreadsheet, is it? So it's two-dimensional. So spreadsheet have rows and columns, is it? So same thing for data frame, it has rows and columns. And both row and column can be labeled. So using named, so we call it row index and column index. So we have named label as index, also named label as column. Then later on, we will see it has a lot of advantages, okay, when you do data manipulation, okay. So here gives a comparison between those two data structures. So regarding speed, both are element-wise operation, so no loop needed, so faster, okay, regarding efficiency. Data type for pandas, data frame and series heterogeneous. For NumPy ND arrays homogeneous, okay. For size, for ND array, we know once we create, you cannot change the size. But for series data frame, they are much more flexible. So the size can be changed. You can use some functions. Okay, we will also see later. And for dimension, series one dimension, data frame is two dimension. For ND array, it can be 1, 2, and even n dimension. Okay, so regarding dimension, then if you have a higher dimension, then you need to use ND array. So then discuss the data structure. So the very first thing is how to create the data structure. So to use pandas, then same thing as NumPy, you need to import the package. So normally what's this statement is import pandas as PD. So you can do the abbreviation, okay? So create a series, we will see our example. Same thing for the data frame. But here at discuss, you can have multiple options, okay? And always use the series method, okay? You can create with default index. So default index basically is 0, 1, 2, 3, okay? Those integer number. So specified index, so they can be named label. So if you don't specify, then it's 0, 1, 2, 3, okay, as usual. If you specify, then you can specify name. So you can also create with dictionary because the dictionary has the key part. So that key can serve as the named label, okay. And then for data frame, you can use a data frame method. And you can pass in dictionary and also list and two-dimensional NumPy array, okay. And if you don't specify, then it will use default index and column. If you specify, then you can specify labeled name for index and column. So for row, they call it index. For column, still call column. Okay. We can also create data frame from file for the CSV. So this the remaining chapters all discussed. We are going to use the CSV file. Okay. So it's comma separated values. So this is regarding how to create the series and data frame. Okay. And for data frame, normally when we do data analysis, the data set is large, is it? So if it involves too many columns and too many rows, it's hard to just look at every single column, every single row, is it? So a lot of time you want to get some glimpse, you want to get overall idea about the data, okay? And especially you can maybe get some sample, is it like the top number of records and the bottom number of records, some general statistic, okay, and some other metadata information, is it? So here are some functions that you can use for data frame header, and if you don't pass the number, then it will by default, it's 5, the top 5 rows, okay, displayed. If you pass in a number, then it will be the top n entries of the data frame. Then for the tail, it's the bottom, okay, and entries. For the describe function, so it will give us some general statistic about the data frame. And for the information function, it will give you total number of entries, data type for each column, okay? Each column. So each column can have different data type, okay? And the number of non-null entries for each column. This is also very useful, okay? Especially when you want to do data modeling. And a major part is also data manipulation, as it also involve indexing and slicing. So we will see, generally speaking, there are there are 4 types. One is you directly with the data frame, and then followed by just like the regular indexing and the slicing, okay, pass in the label. But be careful, this is used to select some single column by its label. Okay, be careful, it's not applied to row, just a column, okay. And there are function dot lock, okay. For this, you pass in the label and separated by comma for dimension, okay? So before the comma, it's a row. After the comma, it's a column, okay? So it's preferable for labeled index and columns. And you can also do slicing, same thing, using comma separated. If you recall previously when we discussed NumPy, we also explained is it for comma, you use it to separate for different dimension, okay? And for the slicing, it's inclusive here, okay? And the data iLock is using number, so not label. Okay, so that's the difference between these two. So this so it use based on integer position, so zero-based indexing. Same thing, you can use it to do slicing, but using comma for row, separated row and column, okay? And also slicing is inclusive. And there is another type called data at, okay, data at. So data at and data I at. So it is also using label data at, so similar to data lock, okay. But it says for data at, it's more efficient for scalar access. Scalar access, okay, so keep this in mind. Data at I at is based on integer position, so dot like a dot I log, but more efficient for scalar access. So that's we are going to use all of this a lot, okay, because you are going to do the data manipulation for data analytics. And we can also do filtering. So filtering is you select some data based on some condition. Okay, so it still support Boolean indexing filtering method. So you can write a Boolean expression to filter rows. And here there's another method called you can do data query. Okay, then in this case you can write some SQL-like filtering expressions. Okay, with column names, comparison operators, and logical operators, and or not. Okay. And there's another method is in, okay. So then this provides specific to filter rows based on membership in a list or set, okay. And later on we will see the examples. And for data manipulation, one part is we need to handle missing data. We need to locate where the missing data is. Sometimes we may need to remove that or to substitute that. Okay, so there are some methods you can handle missing values. So data info, if you recall previously we discussed, is it? So for the data info, it gives you some total number of entries, okay? The rows, the number of rows, data type for each column. This is regarding column, and the number of non-null entries for each column. This is null, so it will return basically a Boolean data frame. So it will return a Boolean data frame. And with this Boolean true or false, then you know what is where the null value is. And for this drop NA, this is to remove the null values. For the drop, you can specify axis as 0 or 1. So this is same axis, same concept like a NumPy, okay? So 0 is for row, for index. 1 is for column, okay? And the how is you can have any or all, okay? And if you don't specify that any is default. So if there is 1, that means then you're going to remove that entry with the null values. And the fill NA is not to replace, but you return, it says return new frame and replace the null values with other values. And if you don't set in place, by default, it's false. If false, it's return a new data frame, okay? Same thing for the drop NA. If you set in place is true, then it will change the original. If you don't set by default, it will not change the original. So it depends on your needs when you do the application. And the second part for data manipulation here we discuss is discussing align data, is it? Because data frame may have different shape. If you recall previous in NumPy, we also discussed this, is it? NumPy has a feature, we call it a broadcasting rule. broadcasting rule, it can expand the smaller array to larger so that you can apply element-wise operation, etc. So similar concept. So data frames can be aligned based on index, okay, before performing operations. And we can also use method align and reindex to adjust the data according to index and column labels, okay. So later on, we will see the example. And so the next discuss is about operations on data frame. Okay, so arithmetic operation. So if the two data frames same shape, then arithmetic operation can directly applied. Okay, element wise. If different shape, then broadcasting or realignment needed to be applied first. Okay. And you can also add a series to a data frame. Then it automatically says align the series with data frames using index. Okay. And we will see that in our example. And you can also apply customized operations. So there are two functions here you can use. The first is called map. Okay, the map is used primarily for element-wise transformation in series. Okay, it said can either by apply a function, you can also use dictionary for value mapping. Okay, and we will see in our example. So you call the map function, then you plug in function name or dictionary, and even lambda expression you can also use. Okay, and apply. Apply is user-defined function. You need to specify access, 0 or 1. Okay, and apply you can support a complex operation. And here it gives us, you can define some functions, then you apply, you plug in the function, specify the access. You can also use a lambda expression. And sometimes you also want sort data, etc. So for sort, it's not just always sort values. The data is sometimes you also want to sort the row or column, etc. Their labels. So then in that case, you have sort index. That's sort your column name or sort your index name. Okay, so sort that by the index label. And you can also sort value. Sort value then in one or more columns. Okay, so when sort value, you specify the column. You can also specify ascending or descending. You can also call the apply function, then pass in some user-defined sort function, then specify the access. Okay. Then in this case, you can sort by rows. Okay, so be careful. For sort value, it's by column. Okay, if you want to do row, then you need to call the apply function to do that. And another operation a lot of time we also use that is discretization and binning. Okay, basically it's dividing some continuous data into discrete segments or bins and categorize the data accordingly. So what you will get is categorization. Categorized data segments. Okay, so there are two functions. One is called cut. For cut, you can apply the series, and one of the column from a data frame can also be a series, is it? And then you specify the bin label, right, true or false. Is it create bins? It's user-defined edges, so you can define, okay, and then categorize the data accordingly. So what it returns is some categorical data type. Categorical data type. This is very useful, okay. For categorical data, when you do machine learning, then you need to find a way also convert it to numerical data, okay. So that's cut. For Q-cut, then it's do the bin categorization based on quantiles. So it divide data into equal-sized segments. Also, what it returns is categorical data type, okay. So then in this case, you provide the bin. We will see in our example. Then in this case, you don't need it. You just specify how many numbers you want. This is a little bit of like, if you recall, that link space, is it? And versus the arrange in NumPy, that link space function, as it is, you specify the number of number generated, or that arrange function. Okay, it's a little bit of some similarity. I think that's the end of our concept part. So next, let's go to the example, okay, the coding part, so that we can have a good understanding. So let's take a look. So this is chapter 3, this is a coding example. And so this first is to verify your Pandas installation and also get the Pandas version, okay? And here is that short script to test your Pandas installation. But anyway, if you take a look, you will see if you want to use Pandas, the very first statement you need to have is that import statement. And in this case, so this variable store a dictionary, so key and value, key and value. So it's a dictionary. And if you want to create a data frame, you can plug in the dictionary to a data frame. So this is Python's dictionary. Then it automatically will generate the data frame. So this is a data frame. If you take a look at the data frame, you will see that, so this ticker and the prime, these two keys, basically, they serve as column names, or we call labels. Okay, so the column. And for row here, we didn't provide the label. So for the row, we use default position numbers. Okay, and if you recall previously for the output of ND array, it doesn't have the index. But here, if you take a look for data frame, it is even though it's just a default position now, it's still listed that. So that's the output. So that's why this is much like a Excel sheet. Is it the spreadsheet? You have row number, you have column name, is it? And then so this part, the middle part, we call it values. This is column and this is index. Okay. So next, first, let's take a look. How do we create a series and a data frame? So first, let's create a series. So you call Pandas series function. And what here we pass in is a Python list. And what it output, if you take a look, the series, the output, it has the default labels, default index. Okay, so here, if we don't specify, it's all numbers. And for the second one, still series. So this time you still pass in a list. Okay, same list. But here, if you take a look, this parameter, the argument index here, you pass in a list for argument index. Then the output, if you take a look this time, so that's the named label for index. So it doesn't have 0, 1, 2 anymore. Okay. So this time, for each entry, it has a named label for it. If you want to achieve that, then you need to specifically provide the list for the index. Okay. If you wanted to know what the index is, you can call the data frame variable, then dot index, the attribute for the index. And if you call the dot values, it will provide only the value part. Okay, and we can see. Let's see the output. The index and value attributes. It is this one. Yeah, so this part for the index, so here it will list the index and also provide the data type, is it? And for the values, what the output is just the numbers, okay? And then over here, it also uses the theory. What if you recall, this is at the very beginning, we define that dictionary, is it? Yeah, you can also pass in the dictionary to the series. And it also create a series. So what the series look like then? If you recall here, then it create this time. If you recall previous, we use it to create a data frame. And all those stock tickers, they are column names, is it? But this time we change it to label, is it index label? You can use it also as index label. So this is the first example. Then for the next example, let's take a look. It's for data frame. For this data frame this time, we have a dictionary. And this iris data is a very, it's a classic machine learning data set, okay? So what it has is, sepal length, then it has a list of numbers, sepal width, pedal length, pedal width, and the species, okay? And then you pass in this dictionary, you're going to create a data frame. So if you take a look this data frame, you see each column, it has a name. So column has name. Okay, but for row, for index, it use default. Default number index. Okay. And it's like previously, if you draw it will basically like Excel spreadsheet, each column, is it, and each row, okay. But when we see here, it's just a plain text, okay, and formatted. So what next shows us is over here, we have a two-dimensional. We defined a basically nested list, okay, kind of like a two-dimensional. You can also pass in this nested list to the data frame function. Then it will create a data frame because you didn't specify index. So the index argument and the column argument, is it? You didn't specify. So they will use default. So the default one are the numbers starting from. So 0 index based. They will use the default ones, okay. And next, let's take a look. Okay, so here similar, we have that list, and then use list, use NumPy ND array, and NumPy array to create a NumPy ND array. And here we define a list. So we have 5 stock ticker, and here we have the year, stock year. Okay. And then this time we create the data frame. So you pass in this NumPy array and you specify index with the list and the columns also with the list. Okay, and then you can create this data frame. So if we take a close look at this data frame, the column has label. Okay, named label column, is it? And for the index, it's also labeled index. So year, is it? So if it's a lot of like the Excel sheet, the spreadsheet, is it? But here it's just a plain text output. You can call the respective attributes. To retrieve the specific index and the column. So it will return you the name of the list of the name of the index and the list of the name for the column. Okay. And values, the same thing. then it will return you the value, okay? And so previous discussion is to create a series and a data frame. So next, let's see how we view and inspecting data frame. And we do need this step because in the real world, your data set normally is large. Okay, it's sometimes even huge. Okay, in this case, then you want to get some idea, some big picture of your data set. So this time we create a data frame with read CSV file. We will use this almost through the whole book. Okay, so this is how you open a CSV file and create a data frame from the CSV file. Okay. So it's pretty simple. We don't, if you recall, last class we discussed this, and also in chapter 1 we also discussed. So that's a lot of tedious work, okay, to do the string processing. Now you don't need to worry any. So this function will take care of everything. So just read the CSV, then it will create the data frame for you. Okay, very convenient. So you want to get some idea about the data set, you can call the header file. And the head, if you don't pass in any number, so by default is a top 5. So this is a top 5 entry, okay? And you can also get index and columns, okay? So here to give you the idea of your data set and the index and the column and the respective column data type, it also tells you. So then in this case, you can kind of, get some big picture of your data set. Because once you have this, then you can start to think about how to process it. And sometimes you also wanted to know what the bottom entries, records look like. Then you can call the tail. If you pass in number, in this case 3, then it will only display the bottom 3 one, okay? And there's another function provide you with some statistic. So general, very general. Statistic information about the data set. So you call the describe function. Very helpful, okay? Normally we use that to get some idea. So it will give you the total number for each column. You see, for each column, it give you the total number. It also provides the mean value for each column and the standard deviation for each column. Or of course, over here is consider if all the data are numeric. Okay, if it's not including some non-numeric, then it may be different. And the minimum value, maximum value, 25% quantile, 50% quantile, 75% quantile. You see, it gives you some statistic information, okay, so that you have some idea, and including the distribution of your data set. This can be beneficial. And the next function is that info function. So what this info tells you also gave you, you see over here, it's total number of entries, okay, and the range of index. Also, data column, it will give you each column, the name and the entry of now counts. This is very helpful, okay, especially with large data set. You will determine if you want to do some of the data filtering and dropping as it cleaning. So later on, we will discuss that, and including data type. And sometimes you may want to do data type conversion, okay, like a casting. Okay, what the next discussing is about indexing and slicing, okay. And indexing slicing, if you recall previously, we discussed there are 4 types. You directly just apply to the square brackets. That's column name, either for indexing or for slicing. You can call data log and data ilog and data add and data I add. If you recall, so we discussed that. So let's take a look. So for this stock price by year, if you recall, what that looks like. So price by year, let's go back, take a look. What does the data look like? Okay. It's this data set. And all of these are made up, okay? It's not the real. So we have 5 stock tickers. We have Facebook, Amazon, Apple, Microsoft, and Tesla. And 4 years, okay? Okay, and with that, so Tesla is 1 column. So you see, you just use column name here, pass in. And if you call dot lock, and here, comma separated. So before comma, this is for all of the entries for row, is it? So if you just have colon, that means all of the rows. And then specify for the column, just Tesla. So this 2 basically are equivalent. If you take a look at the output, is it? And you can also call data ilog. Data ilog, so here, same thing. So before comma, it's the for the row, and after comma, it's for column. So here you use the integer number, is it? And based on what we have discussed and the examples, we can see you use named label, it's much convenient. Then you use the number, is it? Because then in this case, you just remember the name. Because if you remember the number, consider like if you have maybe 50 columns, 100 columns, then it's very hard to remember which column is what, is it? But if you give each column a specific name, then it's much easier to do the manipulation. Okay, and then next, same thing. You can also provide multiple indexing. For multiple indexing, if you just directly want to use that square brackets, then you pass in a list. Okay, and the list containing multiple column names. Then you see over here, you specify 2 columns. That's it. And you can also do data lock, similar. Okay. So here you can use the list after the comma. You can also do data ilock. Then in this case, you pass in a list with number. So this is very similar to NumPy, if you recall. When you have multiple items you want to retrieve, then you can use a list. Okay, and it also allows slicing, is it? Then in this case, so for the column, you can also do slicing. Slicing remember, in this case, it's inclusive. Inclusive, okay. So Apple included from Meta to Apple. Okay, you can also use number. So either way is, but we can see the advantages to use named column or named index. And what next try to show is you get each record is here specify the first year, or you can use data ilock. And if you want to specify multiple rows, so multiple rows, so indexing for multiple rows, then you pass in a list containing the labels for each row. Okay, so that's how you do that. And similar for I.lar, you pass in the number. Okay. And for slicing, same thing. Then it's inclusive. So just be careful, okay? Sometimes here you inclusive, in other case it doesn't inclusive. And what next to try to show here, if you take a look. So here we have comma. So before comma, that's for row. And after comma, it's for column. And here we call the data lock. So if you wanted to deal with both row and column, remember use data lock, okay, or ilock. And for the row, then you specify 2 year, pass in with a list, okay? So this is indexing. For indexing, you use a list. And for column, also indexing, so you use a list. Indexing for multiple items, so use list. Okay, and here it's just a regular slicing, okay, for both dimension. And you can also use dot at and dot I at, okay, it's similar, okay. And what next part covers is about data filtering. Okay, so let's take a look. So read it carefully. So here, this part is data ilock. So you try to retrieve from 30 entries from 100 to 130, etc. And here we just pass in the slicing, no comma, so that's just apply for first dimension. So after you get 30 entries, then what you are going to do is, if you take a look within the brackets, what it is, this is a condition. So it will return true false. So it specify the column, data frames specific column says, okay, greater than 2.3. Okay, it's a paddle width. So it will filter out all of the paddle width greater than 2.3. So it will take off. So you filter out, okay, only those three records meet the condition. So that's how you get some data out using filtering. And then next, it's same thing here. So over here, don't use dot. You use the indexing. Okay, using index with specified column. So that's paddle width. So paddle width. It says paddle width value is in this list. Okay, so is in is check if a value in the list. If it is either 2.5 or 2.2, yeah, if you take a look at the results, all 2.5 or 2.2. Okay, and then it will pick out all of those items. And then what's the next one? If you take a look, so this is the data frames paddle length, paddle length, and then paddle width. So paddle width. So paddle length greater than 7. Here you use the AND condition, and the paddle width greater than 2.2. Okay, so it want to get these two values. Oh, not a paddle, I'm sorry, it's a sepal. Not a paddle. It's a sepal length. Sepal length is here. So it want to retrieve based on this two columns condition. Okay, meet this. Then if you take a look, the result will meet this, okay? And you can also use SQL's query statement similar like that, okay? Then over here, you say, okay, you select the column and put out the condition, okay? And you can also use the AND to build a complex condition. And then you pass in this to the query statement. Then basically these two did the same thing, okay? And we can take a look. If you take a look, you will find is it both deals with sepal length and paddle width, yeah. So they both meet the condition. So that's regarding filtering. And what next to discuss is about handle missing data, okay? Handle missing data, so we are still going to use that stock price by year. So what it looks like, first let's take a quick look. So the data looks like, so it has 5 stock ticker and 4 year, okay? And then what over here we did, we create the first series. First series, we don't have 2015, as you're missing there. For the second one, we missing 2010. Okay, so both have label index. And over here, if you recall, this create a deeper copy, okay? And then you, you create two new columns. So over here, you create two new columns. This is similar, okay, like a dictionary. You just provide the column name and provide the column values, okay, using series as a column. And we can see here, because if you take a, remember, here to missing 1 year, here for the second one, it's also missing 1 year, is it? So how you are going to align it with the original data? So what the result looks like? If you take it, so that's the original part, is it? The left original part here, you have NVIDIA and MU, okay. And if you take a look, the missing year, it will just fill the value with the null value. Okay, that's what it did. Okay, and then next you check, if you recall, is null. So that's a very useful function. Okay, you want to find which entry has some null values, which is specific cell here, is it? So what that is now returned if you take a close look. So this is a true false, basic true, a data frame with true false, okay. So that is null function. That is null. And we can also remove the null. We call it a drop NA. Okay, so this is also very useful when we do data analysis and machine learning. And you can specify how. Okay. So here it says any. So if there is any, you are going to drop, because if you recall, here we have a true. It says so 2010 to 2015. If you take a look, the result, if there is any of it, is it? So it will drop these two rows. And then what next one? So a lot of time you also not just want to drop, you want to maybe replace the null value with some other values for you to use. Is it? Then in this case, you can do fill NA, okay, and then provide the values. So what it returns is, if you recall, for the null entries, it just fill with the new values that you provided. So that's fill NA. Okay, and all of those, they will not impact the original. If you do want the impact on the original, like drop NA and fill NA, you need to specify the in place as true. By default, it's false. Okay. If you do the in place is true, then the original will be impacted. So if you take, otherwise the original won't be impacted. So you see, if when we do in place is true, then it's impacted, otherwise not, okay? So that's a small point that keep in mind. And what next to try to discuss is align data. So still discuss about the original data set. And here we have two series created using index, okay. And then what you next see is you call the first series and call the align function and plug in the second series and specify using what to do the align, okay? So you're going to use the row for alignment. And after that, if we take a look the return result, then you see it will align and filled in with the non-existent one, the non-existing row is it as a null value. And we can also call the reindex, okay? And then you specify some data frame or series index for the index. So it can also do that. So you can use both to do the alignment, okay? And then because of the alignment, and we can also do arithmetic operation, okay? So here we have this data frame. So it has Microsoft and Tesla, okay? If you recall previous, we have 5 columns, including Microsoft and Tesla, is it? So, but this data frame has only 2 columns. The previous one has 5 columns. So if you want to do the arithmetic operation, so the data shape is not the same. So it cannot do direct element-wise, is it? But if you see for the same value, so it did the arithmetic plus operation. Okay, it does do the above. For the remaining non-existing one, then it just fill with the null values. So that's the plus operator. And if you call the add function, then you can provide with the fill value if the value doesn't exist. So that's more convenient than in this case. Then the result will not be just null value. Then it will just do. If it has the matching one, it will do the addition. Otherwise, it will just fill with the null values to do the addition. Okay. And similar, you see, for the next case. So here you create a new data frame. And this time NVIDIA and the MU don't exist in the original data frame, is it? So if you do arithmetic operation, then if you take a look at the result, it will be all null because none of them matches with each other, so it cannot. But if you do that data add and provide with default fill value, then it can do the addition if it does exist, okay? So that's regarding this part. And we just have a little bit of left. So how about let's just try to finish it, okay, not a lot. What is the next is about arithmetic operation, okay? For the arithmetic operation, and if you take a look, so this is a data frame and times this scalar, and so it will element wise, okay? And this time, both data frame are the same shape, so they will do element wise operation. So arithmetic addition, okay? And then what the next one try to show is this is a data frame. So have 5 stock and 4 year, okay? And for this is a series, and it has a 5-year matching with this stock price current data frame. And if you call that add, then in this case, then this series will basically expanded kind of, also have 5 column, and the respective value 1, 2, 0, 3 will automatically, so 1, 2, 0, 3, 1, 2, 0, 3, 1, 2, 0, 3 will be automatically applied to each of the respective cells. Okay, so that's what this does. So if you add a data frame and a series, okay, so it will do the automatic expansion. Okay, and what the next one discuss is about that to use for function, map, and apply. A map is for series, apply is for data frame, okay? So here we have a data frame, pretty straightforward with dictionary. And here we have a dictionary. Dictionary match the ticker and the company name, okay? And then if you take a look, what we do here is for this stock, for this data frame, so this is the data frame, we create a new column called the company. Previously, it only has a ticker and a closing price, those 2 columns. So we want to create a new column called the company. And how do we get the company? Okay, we use its ticker column. With the ticker column, we call the map function. So this is a series. A column is a series, okay? And then you call the map function, then you plug in the dictionary. So it will automatically give you the respective function, company name, okay? So that example shows for the map, you can plug in a dictionary. And what next over here, we define a function, pretty straightforward function. And then this time, the closing price, we try to update the closing price, okay? Then you call the map, you just plug in the function. So for map, you can plug in dictionary, you can also plug in function. So very convenient, okay, because when you have a data set, a lot of time in the real world, you want to do some operation that then you can use this to function, apply and map. So here we define a function for apply. It's for data frame. So that's a data frame. And then you specify what this function is going to apply to the row or to the column, okay? So here it's apply to the column, okay? You are going to apply the mean value for all of the columns. So that's why the result will give you each year's mean value. You can also plug in a lambda expression, okay, and specify the axis. And what is the next one? So this here we call map again, as it. So this is a column, basically it's a series, and you also apply the lambda expression. Okay, so for the next one, it's about sorting. Okay, so we can sort index and also sort value. So for this stock price, that data frame we call sort index, you specify which axis. So here we want to sort the column index. So if you take a look, you will see the index, the column name is arranged as ascending order. So rearranged the column. Okay. So this time, this kind of sorting index can be used a lot in the real world. Is it? Yeah. And you can also sort value. So sort value, then, normally you specify a specific column in this case. Okay. So this time you said, okay, I want to sort by Apple's price. And you said, okay, in descending order. Okay. So if you take a look, here, it's in descending order just by Apple. For other column, they are not sorted. Okay. What next is you define a function for sorting. So here, sort value. Okay. And then you can call that apply function. With that apply function, you specify the axis, then you pass in the user-defined sorting function. So this also used sometimes, okay, in the real world. So you can also call apply function and then pass in a function that you defined to do sorting. Okay, and the last concept for this chapter is about the cut and the Q cut. Okay, so let's take. So here we have the data and we have defined a list. Okay, called a bin. Okay. Then we call the cut function, pass in the data and the bin, both a list. And if you take a look at the result, you will see for each respective value 1, then it's going to be in the bin of 0 to 5. Okay. Then for 7, it's going to be bin of 5 to 10. And for 5, it's 0 to 5. Is it? And for 6, then it's going to be 5 to 10. So the result is some categorical data. Categorical data. Okay, that's what the cut does. Similar, you can call Q cut. Okay, for Q cut, then you specify the number of quantiles that you want it to be cut. And then similar, if you take a look, the result will be specified within each of its own quantile. Okay, so that's the general idea about what today's discussion. Okay, and so basically we finish chapter 3, and